Hello, this video is about SR latch circuits. We have seen bistable 2-inverter circuit that can perform a simple memory function because it can preserve its state as long as the power supply voltage is provided. So we can keep the output of the first inverter at VOH or VOL. However, we cannot change its state, so it does not allow its state to be changed externally. To provide such a change of state so that we can write to that memory, we add simple switches to the bistable circuit. Set for S and reset for R. Here we have a SR latch. For a NOR-based SR latch, when reset signal is 1, next state will be 0. So reset says to reset the output. Similarly, when the set signal is 1 and reset signal is 0, the output will be 1. So it says the circuit to set its output. If reset is 0 and set is also 0, it preserves its state, so the operation is hold. As you can see, this latch circuit has two inputs S and R and two outputs Q and Q prime. The memory elements, flip-flops or latches, can have several inputs, but they should have two outputs, the state Q and Q prime inverse of the state. Here you can see the gate level implementation of a SR latch. Please pause the video and follow the signals and see what happens if S is 1, Q prime is 0 and R is 0, and please check this table. Here you can see the transistor level implementation of the SR latch. We have 4 NMOS transistors and 4 PMOS transistors. So input of one NOR gate is S and second input is Q. For the second NOR, one input is Q prime and second input is R. Now we will look at the operating modes of these transistors. We know that this NMOS and PMOS transistors will work in complementary manner, so we will focus on the 4 NMOS transistors. Here, when set signal is high and R signal is low, when S is 1, M1 will be on and M4 will be off, and the current state, if the current state is 1, then M3 will be off and M2 will be on. Similarly, when S signal is low, M1 will be off, R is high, M4 will be on, and if the current state is 0, then M3 will be on and M2 will be off. Here let's have a look at the hold your state case, which means S and R are both low. So when S is low and R is low, M1 and M4 will be off. So the output will depend on the current state. If if the current state is 1, so Q is 1, then M2 will be on and M3 will be off. Or if the current state is 1, then M2 will be off and M3 will be on.